Hello everyone, I'm trying to use a different technology to try my next lecture. We are doing 2.3 trig equations. What are trig equations? Well, trig equations are equations looking like this. Cosine of theta equals 1/2, for example. You probably thought, okay, it's not a problem to find. They just like look at the table and find the solution. This is correct, but table actually going to give me two different values. And just because we memorize a little table, it does not mean that value is going to be only one. So cosine, everyone remembers, cosine is x, right? So I'm going to choose x equals 1/2 here and find what are possible angles for this x equals 1/2. Actually, I see that there is one angle here, right? And there is another angle here. If somebody is asking me to find theta belonging to the interval from 0 to 2 pi, I probably should not choose a -1 because obviously it's not there. So what I'm going to do, I'm going to write down that theta1 equals, and we remember that cosine 1/2 is produced by pi over 3, right? The angle of 60 degrees. And I'm going to do theta2, and instead of giving -pi over 3, I'm going to write down -pi over 3 plus 2 pi. So it's like this angle and 2 pi together is going to give me actually angle which sits over here. So in our case, we are going to have what? 5 pi over 3. So there are two possible answers. Are they only two possible answers? What is going to happen if I add over here 2 pi? Well, I do know that cosine of pi over 3 plus 2 pi is going to be still equal to 1/2 because 2 pi is a period of cosine, right? Should I include this new angle into my solution? Looks like no, because it does not fit into it. It's already like beyond this interval. But for some cases, we are going to include them. So I'm going to write down 2 pi k over here. 2 pi k means that I'm not going to just add 2 pi once, but I can add it 2 times, 3 times, 4 times, and even subtract it. K is going to be integer. For my answer in interval, these two are going to be enough. So I'm going to write down theta and write down pi over 3 and 5 pi over 3. But generally, answer is supposed to look like this. And this answer is going to work for like all possible values which are satisfying this equation. Okay. Okay, what I want to do, I want to stop it for a second. Okay, let's consider example 2. I'm going to, let me first change my eraser to the draw actually. Okay, so I'm going to consider a different equation. Sine of 2 theta equals, let's do 1/2 again. Well, let's do not think about 2 theta yet. Let's think, okay, sine of which angles is going to be 1/2. Draw that unit circle. We remember that sine is y, right? So if you choose y equals 1/2, that's going to be something like this. Two possible angles. Angle number 1, angle number 2, right? Well, what is angle number 1? It looks like it's 30 degrees or pi over 6. And angle number 2, well, because this is 30, it's going to be what? 5 pi over 6 or 150 degrees. I'm going to write them down. Theta 1 equals 5 pi over 6. Theta 2 equals pi over 6. I do remember that first, they are not theta 1 and theta 2. They are actually arguments of sine, and they are double thetas, right? Second, I have to add this 2 pi k to both of them to make it a most general solution. Now, to find just theta without 2, I'm going to divide this equation by 2. So theta 1 equals 5 pi over 12 plus pi k, and theta 2 equals pi over 12 plus pi k. I divided by 2 each term, this term, this term, this term, and this term. Now, how many solutions I'm going to get in interval from 0 to 2 pi? Well, obviously 5 pi over 12 and pi over 12 are going to be solutions, so I'm going to put them 5 pi over 12. Pi over 12, maybe I should put pi over 12 first because it's smaller. Now, if I set up k equals to 1, here, k equals 1, I'm actually going to have pi plus 5 pi over 12, which is going to give me what? 17 pi over 12. 17 pi over 12 is still inside of the interval. If I want to know what is going to be the limiting one, it's going to be 24 pi over 12, right? 24 pi over 12 is 2 pi. And if I set up k equals to 1 over here, I'm going to get pi plus pi over 12, which is going to give me 13 pi over 12. You see, instead of 2 solutions, I'm getting 4. The major reason is the angle was doubled here first. And second, I did not forget about 2 pi k. When you solve your equation, first do it in general, and then see how many of your solutions possibly can fit in the interval people are asking you to fit for solutions. Okay. Okay, one more equation we are going to consider is tangent of theta minus pi over 2 equals 1. Well, again, we want to choose solutions on the interval from 0 to 2 pi. What is the trick here, guys? The period of tangent is not 2 pi, it's just pi. So first, I'm going to assume that this one is just something unknown, and I'm going to solve it for the whole thing. Pi over 2 equals tangent of what angle is pi over 2? Equals to 1. You know that that's pi over 4, right? Pi over 4 tangent equals to 1. What I'll need to do, usually we add 2 pi k. Here, guys, we're going to add pi k because 1 period is equal to pi. Well, because I'm searching for theta, I'm going to now add pi over 2 to both sides. So I'm going to just make sure that only theta sits here without any additional angle. It's going to be pi over 2 plus pi over 4 plus pi k, which is going to give me 3 pi over 4 plus pi k. Now I'll need to find possible angles which are fitting into my interval. Well, obviously, the first one, 3 pi over 4, is going to work because it's from 0 to 2 pi. Now, if I set up k equals to 1, I'm going to have pi plus 3 pi over 4, which is going to give me 7 pi over 4. 7 pi over 4 is still inside of the interval. And that's going to be 2 solutions. Okay, guys. Now we're going to consider a more complicated example. You see my equation here looks like it is a quadratic equation. Just instead of x squared minus 3x plus 1, I have a sine squared minus 3 sine plus 1. What I'm going to do to solve this equation, I'm going to do substitution. T equals sine of theta, which is going to turn my equation into quadratic one. This quadratic equation can be solved by formula, or you can just factor everything. I'm going to use a formula, but it's not necessary to use a formula. So t equals plus minus square root. 3 squared is 9, right? Minus 2 multiplied by 4 and by 1 is 8. Plus 3 and divided over 2 by 2. So I'm going to get plus minus 1 plus 3 divided over 4. My first solution is 1. So it's supposed to be equal sign. And my second solution is 1/2. So I have two solutions over here. Now we're going to recall that t is not my variable and go back to the sign. So we have first solution, sine of theta equals 1. For which angles theta? Sine equals 1. We do know that there is only one angle, theta equals pi over 2. How about sine equals 1 over sine of theta? So let me kind of erase the sine of theta equals 1/2. Well, we already solved this, right? It was example number 2. There are two possible thetas. First theta equals pi over 6, and second one 5 pi over 6. So how many solutions we have in total? We have 3 solutions: pi over 6, 5 pi over 6, and pi over 2. Okay. The secret here was to convert equation into quadratic one using substitution. Okay, guys, one more equation we are going to solve. This equation does not look like we can convert it into quadratic one because it's not about one function like sine, 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 or cosine, cosine, cosine. It's about sine and cosine. Until we convert it to one function, we won't be able to turn it into quadratic. How do we convert it into one function? We're going to use Pythagorean identity. Cosine square of theta plus sine square of theta equals 1, from where cosine square of theta is 1 minus sine square of theta. Let's substitute here. 1 minus sine square of theta plus sine of theta equals 2. Now what I'm going to do, I don't want to have a minus in front of the square, so I'm going to move everything to my right side. And I'm going to have sine square of theta minus sine of theta. This one comes with minus. And there's going to be 2 minus 1, which is going to be just plus 1. Well, again, you already know what to do. Do substitution, t equals sine of theta, which is going to turn my equation into t squared minus t plus 1 equals 0. Here, I think what we do, start doing the formula, t equals plus minus square root 1, right? This one is, this coefficient is squared, minus 4ac, right? So 4 by 1 is going to be minus 4. And this already bothers me a little bit. 1 minus 4 is negative 3 less than 0. So I'm not going to have any real solutions here. Though I still can continue the formula, but I'm going to write down no real solutions. If no real solutions are there, well, that's it. That's the answer. Okay. Okay, guys, we are kind of done with this section. What I want to do actually, I want to give you a couple of problems to think about, solve it on your own, and then try. It was me. Okay, guys, I put 2 problems on the board. I want you to try them for 10 minutes on your own, and then I'm going to show you how solution's supposed to look. Okay? I'm not going to make a big pause. You can just stop the video and do it on your own. I'm going to count 3 and start solving them, okay? So 1, 2, 3. And I'm going to solve the first problem. Number 1. Sine of 3 theta equals negative 1. We do know that sine equals negative 1 when the angle equals 3 pi over 2. This is coming from our table, right? So from where theta is going to be what? 3 pi over 2 and divide by 3. I'm going to have pi over 2, and that's going to be the final answer. Should I do more solutions? Maybe I should. So I'm going to add 2 pi k here. And then it's going to be here 2 pi k over 3. Let's see if some of these k's are going to give me solutions which fit into my interval from 0 to pi over to 2 pi. Wow. Let's set up k equals 1. So what I have, theta equals pi over 2 plus 2 pi over 3. Well, common denominator is 6, so it's 3 here, 4 here, and I'm going to get 7 pi over 6. Well, it still fits into interval from 0 to pi. So works good for us. K equals 2. Theta 2 over 2 plus 4 pi over 3. 3 here, 8. 3 plus 8 is going to be 11 over 6. 5 over 6, right? Still fits. But that's going to be the last to fit because 11 is very close to 12, and that's almost 2 pi. So what are going to be the solutions? Solution number 1 is just pi over 2, which sits over here. We can call it theta 0. And there are 2 more solutions, 7 pi over 6 and 11 pi over 6. Okay, that's solution of problem 1. Now I'm going to kind of erase everything, and I don't want to do it using your time. Okay, so I'm going to solve second equation. I'm hoping that you tried it already. So you see that in second equation, we have quadratic one, 2t squared plus t minus 1 equals 0, right? T equals plus minus square root of 1 plus 4 by 2, 1, 2, and 4, minus 1 divided over 4. So I have plus minus, this is 1 plus 4 plus 8, 9, so plus minus 3 minus 1 over 4. And my 2 solutions here are minus 1, right, negative 3 and negative 1, and 1/2. So now I'm moving to solving cosine actually. So my cosine of theta equals minus 1. Well, I know that theta equals pi. There's going to be no additional thetas fitting into it because 2 pi is going to bring it outside of the interval. My second cosine of theta equals 1/2. Well, what are 2 possible angles are producing 1/2? Theta 1 is produced by pi over 3, right? Pi over 3 is doing directly 1/2. And another one is negative pi over 3, which is 5 pi over 3 actually in positive ones. So we do have 3 solutions. Pi over 3 and 5 pi over 3. Okay, well, I think what we'll need a little bit practice on this stuff, some equations. So I'm going to say goodbye and try to do some practice, okay?